welcome to another Unity 5 tutorial. Today I'm going to show you how to use the flocking algorithm to create some interesting effects with fish. Yes, I know fish don't flock, they school, but the principle is still the same. So the flocking algorithm is one that is used for creating flocks of birds and other animals in games. It's also used in movies. So the first flocking algorithm was actually developed for the Lion King to animate automatically all of the herd scenes in that. So we're going to use exactly the same principles of that today. There's 3 rules that are used for the flocking algorithm, and together these 3 rules create some really interesting and quite complex behaviour, as you're about to see. And I'm quite excited because it does bring out some really interesting movements, especially when you're working with the fish and that. So first of all, the first rule, as you can see here, is that a group of animals or game characters or whatever are going to tend towards the center of a particular group. So we calculate the center of a group and slowly turn the animals towards that point. The second rule is that the flock turn towards the average heading of the entire group. And the third rule is that each character animal in the group has to avoid the other ones, and that essentially will keep them together, but also stop them from colliding with each other. So there are our 3 rules that we're going to implement today. Alright, so back in Unity, I've got this little fish here. Now I got that from the asset store, and I'll just show you. It's called Colourful Sea Fish Pack, and it was $10. And it's got a stack of fish in it. It's really great value for $10. He's a low poly model and he's just swimming. So he's got legacy animation on him already, and all the prefabs are in this pack. There are other fish in the asset store. I found a few free ones, and I also found some even lower poly versions. I think there was one for $2, so also good value. You don't have to have an animated fish to do this tutorial. You could just use a cube or a sphere as your object. You'll still see the same behavior. Right, so let's get started. Okay, we just stop running. The first thing we need to do is to create a manager that's going to manage all of our fish and create them. So let's go and create an empty game object, and let's call that fish manager. Now on that fish manager, we're going to create a script called global flock. So it'll kind of keep track of all of the fish for us. So in the assets in project, we're going to go create C# script, and we'll call it global flock, like that. All right, so let's open that up, and I'll move that over for you. Okay, so to create this flock, we first of all need a prefab for our fish. So public game object fish prefab, which we will pass through our fish. And then in the start function, we're going to create a whole bunch of these fish. Now, before we do that, we're going to have a static int, which is the number of fish that we're going to create, so that we can just change this value at the top of the program each time we want to run it and create that many fish. So we're going to work with 10 fish, and after we've created them, we're also going to put them into an array so that we can get hold of them later on. So I'm going to make that public and also make it static so that it's accessible by other scripts. Game object array all fish equals new game object, and that will be num fish. Okay, so that's our array. Now we need to, in the start function, is create a loop and loop through and create all of our fish. Now I've said it before, and people do remind me in my comments on my YouTube channel, is that it's not a good idea to use instantiation, that you should use object pooling. But in this case, we're not instantiating inside the update loop. We're doing it at the beginning of the program, so that's fine. If you weren't ever meant to instantiate, then there'd be no reason why there is an instantiation function. So I'm going to do this in here. This also makes it dynamic, and we can then just, like, we can have 100 fish in our tank if we want to. So we're going to create a for loop, and we will loop around numFish times, and each time we do that, we're going to create a fish, and we're going to stick it into that array. All right, now rather than type it all out again, I'm just going to cut and paste from my previous code that I made. And what this does is it, on the fly, creates a position for our fish in three-dimensional space using random range between this value of tank size. Now, I've made this a variable and forgotten to declare it up the top. So let's just go back to the top and add it in as well. And we'll use public static int tank size equals 5. We're making it public and static so we can access it from outside of this script, and you'll see why a little bit later. And it can be static because it's never going to change. And we're going to then use this tank size on either side of 0. So that means the tank's actual size will be 10 by 10 by 10. And it's going to generate a range around the origin of your world. So this whole code is assuming that 0, 0, 0 is right in the center of a very large square tank. Okay, once we've generated a random position for our fish, we can then instantiate it using the fish prefab and stick it into the array. All right, so let's save that, and let's go back to Unity, and we will attach that global flock script and dump it onto the fish manager. Now, it's got the exposed fish prefab that you can see here, and we can use this fish up here if we make a prefab out of it. So I'm just going to grab that fish and make a prefab. Okay, and I will then use the prefab in the global flock. Okay, so this fish here we could actually delete if we wanted to, because it's no longer needed. Now when we press play, we get, what did we say, 10 fish created at random locations within the 10 by 10 by 10, and you can see them there. The animations are attached. If we just click on here, you can see it's already got the motion of the animation attached, so it's just going to automatically run. I'm not doing any mech anim or anything interesting with these fish. They're just going to continually swim around like fish do. Okay, so that's creating our 10 fish. Now the fish have to move. Now it's not going to be the global flock script manager that's going to drive these fish forward. Each fish is going to have its own little script that will push it around. Okay, so let's do that. So the script that's going to run each fish, I'm going to create that, and we're going to just call it flock. So C# script, call it flock, and then open that up in your editor. Now in the update loop, the fish is going to swim forward. So we're going to put in a transform.translate, and we're going to translate it by a particular speed. Now that speed, which is a variable, we'll put at the top. We're going to make that public because, again, we need to access that from outside this script. Let's make it a float. Speed equals 0.1f. Right, so when this runs, the fish are going to swim forward at 0.1, pretty much multiplied by the change in the time in the update loop. and they'll be swimming forward. So let's just save that, switch back. Let's find our fish prefab, which is down here, and we want to attach that flock script to the prefab. If you find it easier to have a fish living in the hierarchy so that you can access it easily to modify the prefab, then feel free. It's easier to find that way if you've got a buried prefab somewhere. But so this flocking is now attached, and it's going to go at 0.14. So if we run this now, it should create a whole bunch of fish that are moving forward, and you can see they are, albeit extremely slow, but they are moving forward. Okay, if we want to speed that up, we just go back into the flock and set this to, say, maybe 5, and press play. Oh, that's right, it's public, isn't it? So it's going to be exposed down here. I always forget that. It doesn't really matter because we're going to change this speed programmatically later on. Okay, so that's a bit better. Right, so these fish don't start all at the same speed. We can add in a random.range in our start function like this here, and then they will just all move differently. So save it and switch back and play, and yeah, that's a bit better. Okay, so adding a lot of randomness into the algorithm will also give you a bit more believable behavior from your fish as you start to add in the extra code. Now, before we can start programming in the flocking behavior, we're going to put a goal position in our global flock script. So if you open up your global flock script, through the magic of video editing, I've already put this in here, we're going to create a public static goal pos and set it to the middle of the tank initially, and then in the update function we're going to add this here, and what it does is every 50 in 10,000 times randomly it will reset where the goal pos is in the tank. So it's just going to randomly move around, but not too often. Okay, if you find that this is too much, you can put another 0 on the end here. If you want it to change a lot, you can reduce the number of zeros. So you can play around with this, but you don't want it to look like that they're extremely erratic. Okay, so that's in global flock. So save that, and let's just go back and open up our flock code, which has also changed. It now has the flocking behavior programmed into it. So let me go through it with you. At the top, we had speed. After speed, we've now got rotation speed. So this is how fast the fish will turn when they need to turn. If you want them to be slower, of course, you would reduce this value down. Right, we then have 2 vector 3s. One, which is the heading direction, the average heading direction. So remember, that was one of the rules of flocking, was to head towards the average heading of the whole group, whilst you're also heading towards the average position of the group, which we're going to store in here as well. And then we're going to have a value of neighbor distance. Now, this is the maximum distance that the fish need to be in order for them to actually flock. If they're outside of this distance from each other, then they won't take any notice of each other. So they're only going to sort of flock if they're near each other, which gives you some interesting behavior, so that some fish will go and swim off into the distance and others will flock, and then at other times, if they get far enough away from the group, they will then going off by themselves, which is pretty ordinary behavior if you do watch fish swimming around. Okay, so start function's still the same. Our update function has changed. It's going to call this apply rules function that we're going to write in a moment. And it runs this apply rules 1 in 5 times, pretty much randomly. You don't want to apply these rules every single update, okay? Otherwise, you won't get sort of random behavior in the fish. And sometimes you do just want them to swim off under their own steam without having applied the flocking rules. If they're flocking too much, you might want to increase this value here so that they don't flock so often. Okay, now for the function that's doing all of the work. It's this apply rules function. Okay, so in order to apply the rules, which is to work out our average position and our average heading and our goals and all those sorts of things, each fish which this code is attached to needs to know about all of the other fish that are with it. And that's why we created a public static from that all fish array at the beginning, which is back in the global flock script. So here we're just grabbing a hold of it with this thing called goes, and which stands for game objects. We're then going to calculate the center of the group and also an avoidance vector, because while we want our fish to swim towards the center of the group that it's in, it also needs to avoid hitting anybody that's near it. Okay, so we need that vector as well. We're setting them initially to 0, but they will be calculated. So that this one here points towards the center of the group, this one here points away from any particular neighbors. We then have a group speed that we're also setting initially to 0.1. Okay, so we then grab hold of our goal position, which is the one we created before as another static public value in the global flock script. Okay, moving down through this function. We've got a distance variable, which I'll talk about in a moment. Okay, we then calculate the group size, and the group size is going to be based on who's within that distance from us. So remember up the top that we created this neighbor distance, which was set to, I think it was 2, wasn't it? Let's just go back up. Yeah, set to 2. So if you're within 2 distance, then you're a neighbor, and we're going to count you as part of our group, because we only want to head towards the average center and direction of our group, and the group are the ones that are our neighbors, not the ones that are swimming off in the distance. Okay, so if we're in that distance, then we're going to add up all the centers, add up the group size. We're also then going to say if we get within a really small distance, then we want to avoid it. Okay, so we're in a group if we're two away, but if we're less than 1 away, we're actually about to collide with another fish. So we will calculate our avoid to be a vector that's facing off in the other direction. Okay, we're then going to find the average speed of the entire group by adding up the speed of everybody that's in our flock. So this is where we're grabbing the flock script that's attached to our neighboring fish, and we're using the speed from our neighboring fish here and adding it into our speed total, so that then we can create an average speed for the entire group, which is in the next section. So if we go down to the remainder of this function, if the group size is greater than 0, so if we're in a group, if the fish is in a group, then we calculate the average center of the group, and we calculate the average speed of the group. Okay, we then use the center vector towards the center, add the vector away from anybody we might be going to hit, and then minus that from our actual current position, which will give us the direction that we need to turn into, or that the fish does. And then we're going to say if the direction is not equal to 0, then the fish is going to change directions, which means it needs to rotate, and we're going to use a slurp for that, which you'll have seen in the other tutorials. Okay, so the slurp will slowly turn us from one rotation direction to look towards another without snapping it to that position. All right, so that is the apply rules function, which is called up here every 5 times or so. So let's save it and see what happens. Okay, going back to here, we're going to run it. Our fish are created randomly. Now, they're going to continue off in a line, so we might have to just check what's happening. Sometimes you need to restart it because they might not be close enough for the rules to affect them. Okay, these two here are now starting to, and yeah, and I'll start again. So they're going to continue moving in their own direction unless the rules are applied or they've got a particular goal position. Okay, so those two there have actually started to flock together, but then they get far enough away and they disappear. So every time you run it, you will get a different behavior from the fish. Okay, what I'm going to do is increase that neighbor value. So let's just say if we're in distance of 3, so that more fish around us will affect us. Let's run it. Okay, so now you'll notice more of them are flocking. And once they do go fast enough and move off, they will just continue and fly into the distance. But that's okay. So we've got that flocking mechanism working. We now need to do a few tweaks to get them to flock better and also to keep them within our tank, because currently they're just going off forever and they'll never come back, because once they're out of range of any neighbours, you'll never see them again, basically. All right, so I've modified the flock script now and just added in some restrictions to stop the fish from swimming outside of a restricted area. So when they reach the edge of the tank, you actually want them to turn around and head back towards the center. So I'm putting in a Boolean value at the top of the flock script, setting it to false initially. Now that will get set to true when the fish reaches the edge of the tank boundary. So let's go down to the update, which is the only other part of this code I've now changed. And it's been rearranged a little bit. So we're testing the distance between the fish's position and the center of the tank. And if it's greater than the tank size, okay, so that was our static global tank size we created before in the global flock script. If it's outside of those bounds, then turning is going to be true. Now, if turning is true, then we're going to calculate the direction back towards the center of the tank and slurp the fish around to there. It's a nice term, isn't it? Slurp the fish. But you know what I mean. So we rotate the fish around, and then we also at the same time give it another random setting for its speed for a bit of variability. Now, if we're not going to turn around, if we're not outside the range of the tank, then our turning is false, and that will then bring us down into this else part of this if turning, and that will run our flocking rules again, still 1 out of 5 times, and then we will translate anyway. So we'll translate if we're turning, and we'll also translate if we're flocking. Okay, so that's all I've added there, is the turning at the top and just the new update function. Okay, so save that and go back into Unity. Now when we press play, we get some really nice flocking behavior from our fish because they're constrained in the tank. And you can actually watch them for quite a long time, and it's just those 3 simple rules and that little bit of code that is creating this really complex behavior. So you've got this school going on here. After a while, look, there you see, this guy's just decided to swim off, but now they're all going off together. But eventually one won't turn as fast, or one will miss the markers going just outside of neighbour range and will head off in another direction. So now they're all schooled together just by complete accident because of the way the fish were going. And remember that at random, you've got that goal pos changing around the tank. Let me just show you that. It's quite interesting, and it takes away the fascination of what's actually going on in there when I put it in. So let's go to the global flock script, and let's add in public game object goal prefab. And I'm going to set the goal prefab's position to the goal pos here. So goal prefab dot transform dot position equals goal pos. All right, so to save that, go back into here and go to the fish manager. Now it's after an object that's going to be our goal pos, so we can create a new 3D object sphere, which is located at 0, 0, 0 by default, which is where the first goal position actually is. And I'm just going to resize this, make it tinier, so it's kind of out of the way. And in the fish manager, I'll set that sphere to be the goal, so that as the goal position moves around with that random code, you'll be able to see it affecting the fish's behavior. Okay, so notice how they change direction every time that goal pos is moved. And the goal pos has 50 chances in 10,000 at the moment of moving. So sometimes it will hang around in the one spot for quite a long time, like it was just before, and then other times it will dart really quickly. And it gives you some really interesting movements of the fish. So one application of this, and you might have seen it in sort of aquarium type games, is where you can drop food into a tank, and you could do that here. It's the same principle as that. The goal pos would be where the food has been dropped. I could honestly sit here and watch this all day. I really love fish. Okay, so that's the basics of our flocking algorithm, or our schooling algorithm for our fish. You could create different schools and have different species of fish flock together. You can try changing all of those different values, like the speed of the fish, the rotation speed of the fish, the nearest neighbor distance, all of those sorts of things, and you'll get really complex behaviors with that little tiny bit of code. It's just fantastic. Okay, so that's the end of this tutorial, and I hope that you enjoyed it. What I'm going to do in the next tutorial is to continue on from here, but actually show you how to style a fish tank and put in some ground and put in some lighting effects and underwater stuff so that it looks a bit more interesting, and we might throw in a few more different fish species as well. So I will see you on the other side.